Welcome, my dear students. This is going to be the last lecture pertaining to week 5, the 5th lecture. In the last few lectures, we deliberated on the conversion of these agricultural waste to useful resources, whether it is in terms of any fertilizer, whether it is any terms of soil conditioner, or whether it is in the terms of any form of energy. So, in this class also today we are going to look at with finer or minute details related to those bioenergy development. That means the development of energy resources from these waste material. As a matter of fact, this is going to be a very important perspective in order to achieve those sustainable development goal. When we are looking for attaining those sustainable development goal, and also we are trying to make sure that those climate action SDG 13 is being met up, definitely these are few initiatives that have to be taken at our own level. In today's lecture, we are going to see that how these resources, how these agricultural waste resources can be converted to bioenergy with those mechanisms as well. At the same time, we will also like to see that what are the factors for making the best efficient energy out of this particular resource material, means your waste material. And also we will like to see that what are the government initiative, that government how has provoked these particular issues of these interventions, particularly among the youth. So that we are likely to see in today's lecture. So as I was mentioning that yes, bioenergy and particularly agricultural residues, as already discussed and deliberated, that it hold an immense potential as a renewable energy source. And these residues can be converted to bioenergy through methods like your thermochemical conversions. In the last few lectures, we have seen many of them, whether it is through your combustion or whether it is through those gasification or pyrolysis. And once we talk about combustion, combustion is used widely for commercial purposes to produce heat and power, and the technology is commercially available. That means the resources, the infrastructure which is needed to convert those resources, those waste materials that are available. And they possess minimal risk for investors because these are well proven. And once we have that particular end product, the end product of this combustion is basically thermal energy, which is used for your heating as well as electrification with an efficiency between 20 to 40%. So with that, if we go further, definitely we understand that this particular combustion, basically whether we talk about this thermochemical conversion, this is a promising method for transforming your agricultural waste into energy rich products. Like biochar, I was mentioning number of times in the earlier lecture, that this is becoming a wonderful initiative and intervention to just keep our soil lively. And this becomes a natural conditioner, right? Biochar and bio-oil and syngas. And this process involves applying heat to decompose your organic materials, often and always, as I was mentioning in the last class, once we were discussing those particular decomposition process, whether it is in the presence of oxygen or in absence of oxygen. So mostly in these particular cases, that often it is preferred in the absence of your oxygen and through techniques such as pyrolysis and gasification. And at the same time, once we go ahead with these sort of definitive modes, because either we are going to convert these resources to those particular, whether we talk about those energy or those gases, which is going to be used for electrification or whatever else. So definitely there involves pyrolysis, and this pyrolysis is basically a thermochemical process that converts this huge biomass into energy density liquid fuel. And it is key method for producing your valuable chemicals and motor fuels as well. And at the same time, once we go ahead for these particular pyrolysis, we need some processes, we need some conditions as well. Means the process which is going to be involved during that pyrolysis, That is basically that thermal decomposition process of biomass and in an oxygen free environment. This is that particular conditions that has to be provoked, and it operates at moderate temperature. And there are temperature ranges. You can see over here that if it is 400 to 800 degrees Celsius, if it is less than, because this is a huge range from 400 to 800 degrees Celsius, and if it is less than 220 degrees Celsius, this is particularly which is used for your moisture evaporation. From 220 to 315 degrees Celsius, primarily particularly for decomposition of your hemicellulose, and 315 to 400 degrees Celsius for particularly cellulose decomposition. And if it is having lignin, the most resistant part, you need more temperature to decompose that. That means you need 400 degrees Celsius. And this is conducted in a closed reactor system with three main stages. That is, one need to prepare those samples, that means those biomass, right, and then followed by your pyrolysis and then your condensation. So biomass must be ground to 2 to 3 millimeter. That means those particle size is very important for efficient heat diffusion, and moisture content should be always below 10% to optimize the process. If it is more than that, definitely the efficiency of that conversion is going to be always low. And inert gases like whether it is your nitrogen, helium or argon are used to maintain an oxygen free atmosphere. And once we do this, definitely you can see from this flowchart that how raw material is being incorporated into the system through the process of drying and then grinding and bringing to that particular desirable particle size, and then it is put into that particular reactor, which is basically that pyrolysis reactor, and then you have a cyclone, and finally you have a condensation, right. And in the process there will be heat has to be put into your system so as to do these sort of processes, whether you talk about those pyrolysis, whether that sort of condensation to take place. So, and once you follow up this sort of module or that particular protocol, definitely you will be able to derive your bio-oil as well as biochar, which basically acts as a very carbon rich material, as well as it is a very good soil conditioner as well. So we understand this particular process of pyrolysis, and at the same time we need to understand that this pyrolysis basically generates bio-oil, biochar and syngas. And mostly the resultant product is mostly dominated by your oil, right. 60 to 70% of that is being dominated by your bio-oil, and then followed by your biochar and then syngas. And depending on those conditions, depending on those particular biomass characterization, biomass, the nutrient profiling, and as well as the moisture condition, the temperature, everything is going to be governed by it. And bio-oil, basically this is a dark brown liquids separated into a organic phase used as fuel, and an aqueous phase high in oxygenated compounds unsuitable for particularly for fuel use. And biochar, as I was mentioning, that carbon rich, it's a carbon rich residue used as a solid fuel and water treatment adsorbent and catalyst material, as well as it has a huge use particularly in your sustainable agriculture. Syngas, this is basically composed of your carbon dioxide, then carbon monoxide, then hydrogen, then methane, ethane and ethylene, and trace gases like your sulfur dioxide, sulfur oxides, right, multiple sulfur oxides, as well as your ammonia and propane. An application of these particular pyrolysis products, basically I already mentioned and emphasized on that particular, whether you use it as a bio-oil, whether you use it as a biochar, or whether you use it as a syngas or catalytic pyrolysis. These are multiple areas or domains where it can be used. And if we talk about bio-oil, definitely can be refined into a high grade fuel or used directly with minimal processing that is possible, because that is the most of it. As I already mentioned, the most of this particular secondary products which is going to be produced, mostly it is your biooil is going to be produced and followed by your biochar. This is utilized for your carbon sequestration, particularly in soil and water filtration and soil improvement. If you wanted to improve your soil physical, chemical and biological parameters of your soil, definitely one need to use this sort of biochar. And syngas, this is used for electricity and heat generation and hydrogen production and biofuel synthesis. Catalytic pyrolysis, this basically this is going to enhance the yield, lowers required temperature and improves your fuel stability. This is most important. The next important part is, apart from your pyrolysis, is your gasification. Gasification is basically the partial oxidation of your carbonaceous feedstock to produce your fuel gas, basically syngas. And the goal is to maximize this fuel gas production while minimizing condensable or those hydrocarbons as well as unreacted chars. And composition of syngas is basically dominated by your hydrogen, followed by you will be able to see your methane as well as your carbon dioxide and carbon monoxide will be there. So, you have a admixture of all of them, whether hydrogen, methane, carbon dioxide and carbon monoxide. And nitrogen, light hydrocarbons, water and contaminants like your tars, ash, char and oils is also going to be there within that particular syngas, right. And pre-treatment particularly of this particular feedstock, because if you are going to dry it at 100 degrees centigrade, basically we wanted to just get rid of those moisture, because moisture maintenance is very important, and shredding to achieve a uniform mixture before entering it into your gasifier. Once you are putting those particular material or those biomass uniformly, so definitely the process yield or the conversion is always going to be improved. And this gasification process basically occurs in a gasifier at a temperature between 800 to 1600 degrees Celsius and uses steam, air or oxygen as a gasification agents and requires nickel based or alkali or alkaline earth metals catalyst to lower reaction time and temperature. That means these are going to facilitate or speed up the process of this reaction. So, we understand that pyrolysis and gasification is going to be a main component, particularly once we talk about your bioenergy production. Now, the question will come that yes, in the process of going ahead for that particular bioenergy, so definitely there are few factors which is in choosing that particular biomass, because once we started working with those precursor, so what are those factors which are very important and which is determinative also in making or in facilitating the process of pyrolysis and gasification. So, the first thing is moisture content. High content always enhances, right, and heating value, higher value always makes your process very rapid. Proportion of bound carbon and volatiles. High content is preferred with low oxygen content, particularly whenever we look into this particular attributes in your biomass, definitely we have to looked into this with reference to those bound carbon as well as volatiles. Content of ash, it has to be the low, the percentage should be low. Content of alkali metals, definitely it is going to interfere in the process whether you talk about pyrolysis or gasification. So, it has to be low, means what I am saying is the desired value has to be low, and cellulose lignin ratio, which is very important, because from the very beginning I was talking about the nutrient profile as well as this nutrient profile is very important, particularly if we have a high cellulose and low lignin, it is always going to give this process or speed up this process at a very faster rate. And now comes the factor which actually influences. Initially we have seen that what are those factors which is needed, particularly the desired attributes which are needed particularly in your biomass. Now you are likely to see that what are the factors which actually influence this pyrolysis as well as gasification efficiency. The first is biomass composition. From the very beginning I am giving emphasis on this, whether you talk about cellulose, hemicellulose and lignin, their percentage, their profile is definitely going to be a very, very important contributor in this particular process. A higher lignin content accounts for slower decomposition, that we understand, because you need a very high temperature for decomposition. Biomass particle size, I was giving emphasis on this particular part. If you wanted to the residence time of those particular particles, their addition, their attrition rate, as well as the entrainment in the reactor. So particles with a size of this size 0.15 to 0.5 millimeter basically enhances the total gas release. So we have seen the biomass profile, this is very important. The next important parameter is definitely your particle size. Then biomass structure, that highly porous biomass creates resulting pyrolysis and gasification reaction proceeded simultaneously. So that whether that material is porous or not, or whether it is a compacted structure, definitely it is going to make difference. And temperature, higher temperature always reduce the production of char and heavy tar, but increase the total gas yield. But achieving that high temperature is always going to be a huge challenge, but it is going to enhance the total gas yield always. And gasifying agent, particularly with reference to whether you talk about air, whether you talk about oxygen, steam, or a mixture of these, definitely the steam gasification was more efficient. Conversion of this methane to hydrogen will be always better. And catalyst, because for bio oil and oil, this is going to reduce your moisture content, remove oxygen, and crack basically heavy aromatic compounds to produce smaller structures. And zeolites, calcium oxide, calcine, dolomite, nickel, aluminum and iron oxides are good examples which can speed up this particular process and actually enhance the process of this pyrolysis as well as gasification. So now there are, as I was mentioning in the beginning, that there are multiple initiatives taken by the government, whether you talk about at the regional level, at the state level or at the national level, and these initiatives for assisting this crop residue management rationally, so that it can be addressed properly. So the Indian government has implemented several initiatives to address this crop residue management, right, to reduce these harmful effects. Whether, because in the very beginning we have seen that how stubble burning can create those chaoses. So here are some of those key strategies which government has taken in the last few years, particularly submission on agricultural mechanization. So this program provides subsidies to farmers for purchasing those crop residue management machinery. When I was discussing, probably in the third lecture, there I have categorically shown that how these, no-tillage machinery and how efficiently can retain those residues into your soil. So whether you talk about happy seeders, straw baler and happy straw choppers. So these are the things which government is coming up and helping farmers either in a custom hiring center basis or through your FPOs or SHGs. So definitely they are doing this particular initiative. There is another program, very important program, Rashtriya Krishi Vikas Yojana. Under this scheme, financial assistance is provided to farmers and cooperative societies and farm producer organization particularly, establishing custom hiring center equipped with crop residue management machinery. So having similar objective what I was mentioning, submission on agricultural mechanization. Under RKVI program, the government is trying to popularize this sort of machinery which actually helps in retaining those particular residues, right. We have Pusha decomposer. This is even in our institute also, in the University of Banaras, in the university, we have also come up with some sort of consortia. Likewise, Pusha Institute in Delhi, they came up with some sort of microbial consortia which is capable to decompose those residue at a very faster rate. So there are and this can be done in situ, means you need not to bring those resources to some other place, you can do it on that particular place itself. So waste to energy program, this is another very important program. The Ministry of New and Renewable Energy, MNRE, they supports basically projects that convert agriculture waste into biogas, bio-CNG or electricity. So this is a huge opportunity for making use of or leveraging this particular resources into some useful component. awareness campaign. There are, related to these particularly, we need to sensitize the mass about the, what is the, potential of using these resources, and what may be the stresses that we need to face if we are not properly, managing these resources. So information, education and communication activities are conducted to educate farmers about sustainable practices and the benefits of crop residue management. So these are your few crop government initiatives for assisting your crop residue management. Now, if we look at the future strategies of your crop residue management, how we need to address these issues, because this is coming up heavily. The waste is going to be generated at a very high rate in times to come, but we need to have a very sound policies and practices in place. So based on sustainable and innovative approaches to address this environmental concern and enhance agricultural productivity, there are multiple strategies are there. In situ management, we mentioned that the techniques like mulching and using microbial decomposer can accelerate the breakdown of crop residue in the field, enriching your soil health. We have that sort of bioenergy production. We need to make some sort of that conversion of those your crop residues into biofuels, and we need innovations in this particular sector, and biogas and biochar through your technologies like gasification and anaerobic digestion, and this can provide renewable energy while reducing your waste. We have custom hiring center. These has to be propagated and infiltrated across the length and breadth of the country, because this is small farmers cannot afford those machineries. For that, we need to have those sort of custom hiring center. And then incentive based models means providing financial incentives to farmers who adopt this sort of sustainable management or sustainable practices, and that can encourage this widespread adoption of these eco-friendly approaches. We need to involve the public players as well. That means those public-private partnership model has to be reinstigated and has to be looked into. So collaborating with private sectors for investment in bioenergy products and residue-based products can drive innovation and scalability. Awareness and training, which is a must, because once we need to sensitize this sort of initiatives and those awarenesses among the mass, particularly the small scale or the small farmers, definitely we need to educate them, and once we educating them the benefits of those particular sustenance or those sustainable agriculture or those sustainable residue management, and we can also provide them hands-on training. And that means, if we can provide them that sort of hands-on training, that is always seeing is always believing. That means we need to put some sort of, result demonstration plots as well. And policy support, which is very important, means you need to have a, sound policy, means strengthening policies to promote residue recycling and penalize harmful practices like stubble burning can ensure compliance and long-term impact. So these strategies are always aimed to balance your environmental sustainability with economic benefits for your farmers. And this is a must if we wanted to see that these particular residues, the residues which we produce, and most of it can be converted into some useful component, definitely we will have a win-win situation. And if we now summarize today's lecture, definitely we understand that yes, once we talk about those bioenergy sector, that in case of bioenergy, the two processes is very important. One is your gasification, another is your pyrolysis. And there are multiple, segments within that particular, component, whether you talk about gasification, whether you talk about pyrolysis. So for enhancing that particular process and enhancement of your efficiency, because ultimately whether you talk about bio-oil or oil, or whether you talk about biochar, or whether you talk about those particular other gases which can be used for your energy conversion or electricity generation, definitely there are multiple factors which affect, whether you talk about those biomass, the nature of biomass, the structure of biomass, which are everything, they are very, very important, as well as most importantly, once we talk about this gasification and pyrolysis, one thing is very important, which is related to the process conditions, whether you talk about with temperature, whether you talk about with moisture, the moisture content, as well as the level of the catalyst and the nature of catalyst which you are using. So these all actually simultaneously help these processes to generate with more efficiency. So with these, definitely we understand that these resources means these waste, agriculture waste, can be converted into useful resources, right. So particularly if you wanted to go through further reading, there are few references which I mentioned over here. If you can go through these references and resources, you will be having a greater outlook of it. Okay. So these understanding is definitely is going to help you to have a more exposure, particularly with this sort of exercise or with this sort of intervention when you are likely to do it in your ground. So thank you very much for your all attention. So we have finished this fifth week, and basically where we deal with these particular in the sectors and with the 5 lectures, and segmented differently for with different heads. Thank you very much.